Okay, so thanks everybody for joining us this week again for the Summer Institute. This is the last session of today. I'm Marty Candice. Again, I work in the HPC User Services Group, and today I will be talking about data management. I think I saw that Cindy has already placed the link to the GitHub in the Slack channel. So I actually don't have any slides for this presentation. I actually have just a series of exercises that I've put into the GitHub repo itself. So if you want to click on that link and open your browser, that would be good to do now. You will get to the front page, and if you scroll down, this is where we'll begin. Okay. So I'm going to go ahead and just turn off my video here. Let's see if I can figure that out. Save on some bandwidth. And okay, I think we're all set up here. I'm going to close the Slack, but I should get notifications if you have any questions along the way, or want to point something out along the way in the main room would be helpful. If it's related to the talk, I should get a pop-up on my screen so I'll be able to see it. And so we have about an hour and a half here for this talk on data management. I'm not sure if we'll get to everything. This is sort of my first time going through this material. It was specifically developed for today's session. So hopefully we'll get to it all. I think we might be able to. But if not, and you have questions later, always feel free to ask in the Slack if there's something I didn't get to. If you're going through the material later this week. So so this talk is really about how to and how not to handle your data on an HPC system, specifically like Expanse. There's a few different topics we'll cover with respect to file systems, data compression, archive files, checksums, downloading data from the internet, and that's how the talk is sort of organized. If you want some references to some more traditional slide material that some of this is based off of and what we've done in the past, I've also put a link to two talks here. One is an interactive video, I think that Mary's mentioned, by one of our former colleagues who went through, who was the first one to give this data management and file system talk maybe 2 years ago now. And then a more recent updated version of the same slides from that talk is available here, if you're interested later, that Mahidar gave earlier this year. But for today's talk, we're going to walk through this series of exercises that I think will be helpful, sort of give you a flavor of the things to think about when you're working with data on HPC systems and some of the problems that people run into, or the things they don't necessarily think about, or a few things have been touched on today in some of the earlier talks, but this will hopefully give you a more, the idea is to really make this a hands-on experience that you can follow along with. So if you can, try to keep up. I'll try to, push things along if we get stuck in certain spots with people having issues, but that's sort of the idea. Now, the first link where we start was before we begin, there's a few disclaimers, right? And the first one is, HPC systems and, like Expanse run on Linux. So if you're not working on Linux and you're running a Windows system, you might not be able to follow along unless you have your system set up ready to do all of the exercises. Some of the exercises, mostly later on in the data transfer section, will push data between Expanse and your local machine. So I'm running only Linux on my machine. If you're running a Mac, you'll be fine. If you're running Windows, you'll have to, hopefully we can talk about some tools that maybe some people who in our group that run Windows think you might like. My recommendation for Windows users always is, if you're going to be working on these HPC systems, for the next few years, there's also the nice Windows subsystem for Linux that you can download and install, almost a complete Linux distribution inside of your Windows machine, and get practice that way. So it could basically give you all the basic tools that you'll need to do these exercises as well if you don't already have it installed. Okay. And then the second caveat to this talk is really there's a lot we could talk about when we talk about data management, right? There's all sorts of aspects to the life cycle of managing data from a given project, right? To planning and designing, what type of data you're going to collect in the project, how it's going to be analyzed, how you're going to distribute that data, how you're going to maintain it over time. This really is a talk about this core part of just the practicalities of managing and storing data efficiently and effectively while you're working on an HPC system, right? So there's this nice graphic, though, if you want to read a little bit more about sort of the broader aspects of HPC data management. This was a really nice site that I found at the Harvard Biomedical Data Management. So there's lots of more information there about the more sort of general topic of data management that you can check out there. But that's not what we're going to cover today. We're really only going to cover the core things of the core ideas that I think are useful for you to know when you first start getting working on a system like Expanse. Okay. So the first thing we're going to do, which I think no one else has done it yet. So one thing that'll be really easy, or very helpful for not only this talk, but for other talks later this week, was I wanted to set up SSH keys. So I want to kind of walk you through how you can do that. If if you have a Mac, this will be straightforward. If you're running Windows, you can kind of ignore this and you'll just have to use your password if you don't have sort of a Linux environment set up yet or a shell. This is really only for Mac and Linux users. Okay. But if you haven't set up SSH keys before, I definitely would recommend. This is something that'll be very helpful when you work on multiple systems, right? So you don't always have to keep typing in the password. That's sort of one of the goals for this exercise, just so we don't have to keep typing in passwords as we work through a bunch of the exercises. Okay, so if you scroll down, so SSH is just the secure protocol that we use for logging in and talking to remote machines, essentially, right? So this is how we will interact with Expanse today, right? And we were given a password for logging into the system that Cindy sent out last week, and I think you should be able to log in. Everybody's been able to log in and confirm that they can. This is just one other way to make it a little bit simpler as you work through everything this week. So it also gets you prepared for this is how this session will go, where I don't have a lot of text material to re-describe to you. I really just have commands that we'll walk through and talk about for right now. And so the first one is this SS keygen. So this SS keygen command you can copy from the markdown file here just by going over to the far right of the text box here on the page. Yeah, thanks, Nicole, for helping out the Windows folks if there's anybody there who needs some other advice. And this is how you would generate your first SSH key if you haven't done that before. So SSH keys come in pairs. There's one that's private and there's one that's public. And so this is the command that you use to create the keys. The options here to the command are the type of key, the number of bits in the key, like how long the key is, and this A factor adds a little bit of extra protection and confusion to how the key gets generated. So it's harder to sort of brute force hack it if someone gets a hold of your keys. And then this -F is pointing to the name of the key that we're going to generate. So for this example, I just wanted to generate a key that is specific for this week. So you can create your own key later. I'll show you what the default name usually looks like if you're not familiar. So if you copy and paste that key into your terminal, it'll generate the key pair. Now, whenever you generate a key pair, what you really want to do is add a passphrase to that key pair. Okay, so you can think about it this week. This is your custom password, right? So you don't have to remember that long, weird password that we gave you for logging in, you can now type your own password or this passphrase for your key. So that's what I'm going to do here. Right? And this protects your keys from someone else using them in case if they get a hold of your system, right? So anybody who has the private key to your public key can log into any system where that public key has been placed, right? So the public key you put on other machines that you want to log into, the private key you keep on your local machine and hopefully secure and away from anyone else who might, want to use your key to get in those systems that you have access to, right? So this passphrase is this extra layer of protection that, even if someone steals your private key, they would need to guess what your passphrase is, right? So it's sort of the password to your key, you can kind of think about it. So you always want to use a passphrase. That's kind of tip one for SSH keys. If you don't use a passphrase, your security team at your university is probably not going to be happy. So that's the output you should see if you've generated your key pair. If you try to run it twice, you'll see, if you've already accidentally tried to run the command twice, you might see that it's trying to overwrite an existing key. If that's what you got, that's what that other output might look like, and you just want to hit no there. And if you look on your local system, right, in the home directory, there is this hidden directory, this .ssh directory, where the keys live, right? So here is the private and public key that were generated by the SSH keygen command, right? You can see here I have another key pair. This is the default RSA public key, private public key name if you weren't to include this -f flag to the command, okay? So that's why I use this -f, just so we have a specific key just for this example, just for this week, right? And so that's really step one. You just need to make that key pair on your local system. The next step, obviously, is to copy your key pair or your public key to Expanse, right? So this next command that you'll copy is this SSH copy ID. Okay, paste it into your terminal, but not run it yet. If you noticed, it doesn't have a number for your XDTR command or for your XDTR username, right? So you need to fill in whatever username number you were given, right? So this XDTR username is the one that you use for direct SSH login. You were also given a train named user account, and that's only for the portal. So some sessions will use the portal, some will use direct login. We're going to use direct login. My number is 108, so I'm going to type in XDTR 108 and then hit return. And that's going to try to copy my key to Expanse. Of course, it doesn't trust me yet, so I need to prove that I am who I am with my password that I was given. So you'll type in your password that Cindy sent you. And if you are successfully able to type in the right password, you should see some output like this, that your key was added to Expanse, and you should now be able to log in using the key pair that we've generated, right? If you've typed in something like train 108 or some account that doesn't exist, you might see this verification code. I know a few of you have sort of contacted us, and, so if you see this verification code, you're probably just typing in the wrong username is usually the error there. So that's what the sort of bad output would look like. So if you typed in an account that doesn't exist and you see that verification code, that's probably where the problem is. Okay. So that's we've copied now our public key to Expanse. Now we want to log in, right? So step 3 to logging in with your key pair is just copying this command in step 3. You have SSH -I. So this basically is for the identity that you want to use when logging in, right? So you point to the name of the key pair that you want to use to log in. We use this SDFC, SI22 key that we just generated to log in. My account name is XDTR108. So I should be able to log in there. But your computer will probably ask you for your passphrase if it's the first time using your key, right? So you type in your passphrase and then you're logged in. Right? So when we do these workshops, sometimes people ask, can we like reset our password? And you can't because we control your password. But if you want to use a key and set your own easy password to remember, this is a useful exercise to walk through. Okay, so you can see here I've logged in to Expanse now using my keys. However, let me show you a few things, right? So when we copied the key to Expanse, it actually ends up in the .ssh directory on Expanse as well. And it's in this, if you check, it's in this authorized keys file, right? So if you look at that authorized keys file, you'll find this long string, right? So it's basically the type of key, this long string, which is your public key, and then the name of the system is of where the key was generated is usually tacked on to the end. Right? And if I go out here, you can go into the SSH directory here and look at on your local system. You should see that this public key on Expanse is the same as the one that's listed here. And so, it's usually you're not, going to look at every single letter here, but you can, kind of just eyeball it. And I usually look at the last few characters, plus P1 RVU plus 1 PRVU. So those are the same public keys you can see. You can also see on your local system with this SSH add command, what keys you have loaded, right? So when you give that passphrase, your key gets loaded into the local SSH agent on your system. And so there's this other process that's running on your local system that can manage your keys for you and help you make that login process even simpler. So, right, when I log back into Expanse now, I won't even have to give my passphrase again, for example, right? Because it's being managed by this SSH agent. Let's see, what else did I want to show you here? So yeah, this SSH add, you can check the keys on both systems. Yeah, the one thing about this SSH add command that I gave, you can see that it gives you a shorter hash too of the key that was generated. And so you can actually, if you log back into Expanse, like XDTR, I'll use the trick that Andy mentioned. You can just scroll up to the last command that you ran. Okay. And you can also check this SSH key gen -L-F. You can check the short hash of the key, the public key that was uploaded with this SSH keygen command as well. So you can see here on Expanse, I only have one public key now in my authorized keys file for my training account. If I scroll back up here, right, I have a few different keys, so I have more than one myself. But you can see which one was uploaded is this last one here, this BI30EG. So that's the key that was actually generated for the Summer Institute and uploaded to my training accounts, right? So that's just one way to verify which key is which. Sometimes people like to have multiple keys for multiple systems. Personally, my preference is to have one pair of SSH keys for my given local machine, and I use that to every system from that machine. And then if I get like, for example, I just got a new laptop, and so now I have a new set of keys for this new laptop versus my old one. So that's what I do. Some people do it differently, but that seems to be, refreshing your keys. Every new laptop is probably a reasonable thing to do, as long as you're careful with your keys and have a passphrase and everything like that. Okay, and the last thing in this exercise is to log out of Expanse, and we want to make it even simpler. If you're not familiar with setting up SSH keys like this, there's also an SSH config file that you can set up in the .ssh directory. You see I have this file called config. And what we're going to do here is you're going to add the texts. If you don't have one, you can run this command, touch, it'll generate that config file. If you need to set the permissions on that configuration file, because when you set up these SSH keys and these configuration files in this special .ssh directory, usually the Linux distribution will like warn you if you don't have good permissions set on there, right? So for example, in general, you want only you to be able to read and write to, say, your config file. If you're working on a shared system, allowing other people to manage your SSH directory and files in there is obviously probably not recommended, right? This is where you can get into security issues. So that's what this second set of commands are, is just setting the permissions on that file, this config file. And then this is the text you actually want to put in, right? So I have this text here in mind. I'm going to type in host expanse, hostname, login.expanse.ssc.edu. And then I'm going to attach actually the specific username, right? So I have multiple usernames on Expanse. For example, I have my mcandice username over here. Right, this is on Expanse. And you can actually point to the specific key that you want to use for that username and for that login, right? And so what this allows you to do, is log in with just a quick alias, essentially, right? So that, if you didn't see what I did, I just went SSH expanse, right? So because the config file says use the XDTR 108 name, it knows which key to use. It knows to use, the long login.expanse.ssc.edu, but all I have to type in is the shorthand SSH expanse, and that's all I have to do. So if you've been able to walk through that with me, hopefully you have a really easy login experience for the rest of the week. If not, definitely hit us up in the Slack, and we'll try to help you sort out any login issues you might have there. Okay, but so I will use this shorthand at least for some of the commands, and I'll try to remember to point that out to you when that comes up. Okay, so we're on to the second exercise. So now that we have sort of a secure way to communicate data between our local system and Expanse, and an easy way to log into Expanse, now we can sort of start working with working with data on Expanse, and how to get data to and from Expanse, and so forth. So the first set of exercises here uses this data set from this CFAR data set. So if you click on this link here at the top, you should get to the University of Toronto or something like that. Yeah, is where the source data is. So we're going to work with this this data set. It's just a nice data set. If you're a machine learning person, you've probably taken a class and used this data set for image recognition, sort of example challenges, networks, and things like that. So it's a pretty famous data set. It's consists of let's see, 60,000 different color images. They're very tiny. It's kind of surprising. Like even as a human, it's kind of hard to tell sometimes what picture is what. in these different classes, but it's just a simple set of 10 different classes. You can see the different lists of the types of images are over here, but it's it's a reasonably sized data set. You can find more information down here. It's about almost 150, 200 megabytes, depending on what version you download. There's many different versions of this you'll find on the web. This is the original set from the authors who created it. From this other, it's a subset of this other data set, and there's actually two versions: the CFAR10 and the CFAR100. We'll just be working with the CFAR10. We don't really have any purpose other than just needing some raw data to work with and manage on Expanse. That's the whole idea of using this data set for this exercise. And this exercise is all about downloading data from the internet, right? So if you're not familiar with what's the most convenient way is to do that, when you have a public data set that you want to get to Expanse, there's different tools that you will use to get the data from wherever the source is on the internet to Expanse, right? So thankfully, Expanse is pretty nice in that it has very public access to both to and from all of the compute nodes. Like every compute node on Expanse has a public IP address, and so you can do a lot of different things with that type of access compared to other supercomputers. A lot of supercomputers don't have public IPs on every node, and so that can limit the types of things you can do communication-wise into and out of the system. But Expanse is kind of unique in that sense, and hopefully we'll be able to keep doing that in the future. It's always a security risk when you allow users to run things that have public IPs. But we try to make the system open and useful for science as much as possible. So what you'll do for this exercise is you'll log in, right? So hopefully you can just type in SSH Expanse. If not, just make sure you log in, get a terminal, however you've been able to do it so far. If you have to type in your password still, just type in your password, make sure you're on the system, and at the login prompt in your home directory. Okay. So the first thing that we'll run here is the wget command. So if you're not familiar with wget, it's just a simple tool to download files over the internet. Right? So it's very simple to use. It's the one I use the most often if I'm just downloading something like this CFAR data set. That's what I would use, right? That's my first go-to tool. And yeah, if you're not familiar with it, definitely I would recommend using it, right? So basically what you'll see here in the output is it just repeats like the URL that you're trying to connect to. It, if there's problems or connecting and stuff, it'll pop up here, but this was a live website, everything looks good. It tells you the address you connected to, the port that was used, the requests, waiting response, all sorts of just little bits of information about the transfer itself. It gives you the size of the transfer, the name of the file, and it even tells you effectively the average speed, like or the average bandwidth, how many megabytes per second you were transferring, and how long it took. So again, this is a pretty small data set. So it didn't take very long to download, but you can kind of get a sense with, this is, it took a few seconds to download. So, pushing the data through from the University of Toronto to Expanse, 33 megabytes per second might not seem too bad, but if you have, terabytes of data, that might seem painful, and we'll talk about that. That's where we'll get to sort of at the end, transferring even larger data sets. But this is the first tool for small to medium-sized data sets within, I would say, 10 gigabytes or less. wget is useful. Okay. Now, few other parts of the commands we walk through here is understanding the data that we just downloaded, right? So this first command here, I'm just going to list The directory lists the contents of my home directory, which should just be, in my case, only this CFAR tarball is what we call them. So the type of file that we downloaded is, we downloaded the Python version of this CFAR dataset, but it's wrapped in this tar archive format, and then also zipped up. So there is sort of two different technologies that are sort of uh, in those extensions, right? So if you're not familiar with them, so there's the tar archive tool. So this is for creating large single files of many files. So if you want to sort of batch a bunch of related files together, tar is the tool that you want to use, right? So tar stands for originally tape archive, and so it was originally created to sort of pool together many files into one that could then be transferred onto magnetic tape, right? So you would just run this one big file. I mean, you would want this just, put all these small files into this big file, and put that big file on tape, essentially. Okay, so because, right, I think probably the reason that for this was magnetic tape wasn't necessarily very good at random access reading. You have to sort of find the spot on the tape that you want to run it off, and just take all the data from there, from one point to wherever you want to stop, right? So having these large batched single files was probably much easier to find these sort of tape backup archive files that you wanted to sort of read off and then put back onto a system. Anyway, so and then it's then compressed here with that's what the .gz stands for, right? Now, if you want to work with this data set, what do? Well, you would have to use the tar tool to, what we would say, untar the file, right? So you would type here tar xf and the name of the file, right? So that's what this command here is. If you want to just copy and paste it over or type it yourself, that's the next command to run. And so if we run that command, it should extract the files from the archive. And just using this -x and -f command, the tar tool is smart enough now that it'll know usually what compression algorithm was used to compress the tar archive to. So there's if you look at the tar tool, there's a bunch of different options. Some of them target different compression methods, but if you just get a tarball, download it, use the -x-xf, it'll just extract whatever it can, if it can. So you don't need to actually tell it specifically what compression was used. It'll be able to figure it out for you. Okay, and so what you see here is we have our directory from the tarball. That's the file itself that we extracted. So we can go into the directory and just check out what the data looks like. And you see here that it's actually, if you read the website, it talks about how the data is formatted, right? So a data set that you might be working with is formatted in many different ways. This one specifically is designed for people who want to bring the data into Python. So it's kind of ready to go. It's kind of Pythonized the data set. So it's not even the raw images, right? It's sort of already pre-packaged into a Python native data format in these different batches, right? And you can read about how to work with the different files and how the data is laid out. It's just all in NumPy arrays, different which part of the array is the image for green, red, and blue. And if you want to work with it raw in Python, all of the sort of data about the data is in the description here. But we're not going to use any of that. It's just a matter of playing around with a few example files here. Okay, so we've extracted the tarball. We can kind of see what the what the file layout is in the data sets. The question is, you might have sometimes if you're working with a data set, is how do you know that you got all of the data? Um, like what's, how do you know that the data set we downloaded is the correct one, or that it didn't get corrupted along the way when you recreated it on Expanse? And this is if you're not familiar with it's with these checksumming tools. Okay, so if we go back to the CFAR website, you'll notice that the three different versions of the data sets not only tell you, what type, how it's sort of packaged, the Python version, MATLAB, the binary, the size, but it has this other bit of information called the MD5 sum. This is what's known as the MD5 checksum, and if you haven't worked with these before or just haven't noticed them, you'll notice them if you're sort of say downloading like a Linux distribution or some other set of files. It's a way to confirm that the data that you downloaded is exactly the same. So, right, if you correctly downloaded this file here, you should be able to use this MD5 sum rule or algorithm, this MD5 algorithm, to take that file, all of the bits that are in that file, run it through the algorithm, and it should produce this hash, right? This sometimes it's called a message digest. Basically, it's one of these algorithms that you can run, throw as much data you want into it. It'll churn away on the data that you have and output a fixed size, hopefully unique hash, right? And so this is one way to do this, what we would say data integrity checking, right? And so if we want to prove to each other that we all downloaded the same tarball from the University of Toronto and that we got all the bits that we needed correct, and there's no sort of degradation of the data, you could run this MD5 sum tool and get out the checksum from the file. So, right, and then you can see that it's exactly what was posted on the website. So we know that we downloaded the data without any issues, right? So the data is intact from the according to what the original author had posted on the website. Right, so this is one simple tool to do data integrity checking. If you, for example, are generating your own custom data sets and you want to, talk about publishing it online and making it reproducible for people, putting these checksums out there for people who were downloading your data would be helpful, right? Because then they could prove that the version that they download is exactly the same, the one that you were say writing about in your tutorial or in your paper that you were you published. Right? So this is one set of tools that you'll see people using. Let's see, what else did I want to say? Yeah, sometimes there's also if I click on this one, what I'm going to do here is I'm going to run the MD sum tool again. But this time I'm going to put the output to a file in this command here. Okay, so if you copy this command here that redirects the output of the tool to the file, you'll generate a checksum file. So sometimes what you'll see is instead of someone posting, say, the hash exactly as it is on the web page here, sometimes what you'll see is people post the checksum file, right? So you might just see a file like this that you're supposed to download to then check that these are the same, right? So you can generate these checksum files yourself, and one way to do it is you can do one way to then check or run the MD5 sum tool is you can run MD5 sum check and then just submit a checksum file to the tool, right? So it knows that this -c command is just to say, hey, I have a checksum file. I have the file that I believe is the right one in the same directory. Can you check that it's the same? That's all this is doing. So it's one other way that you'll see people run it, or you'll see people post these checksum files instead of just posting the hash itself somewhere. Okay. Let's see. So the next tool, so we've covered wget, tar, mdsum5. Now we're going to switch back to another download tool. So another common tool for downloading data from the internet is this curl tool. I don't use it too often, but it's definitely got way more features than wget. And curl can also be used to send data. So it's basically it's both outbound and inbound traffic you can kind of send. So it's much more of a Swiss Army knife of a data transfer tool that's commonly used in sort of the Linux world. And so I just wanted to give you one example here of now we can download the data set again, but using curl, just because it's slightly different. You'll see slightly different outputs. If you want to copy the curl command here and paste it into the browser. It's just slightly different types of output, but again, kind of similar information like how much data was transferred, what the average speed was, and even how long it took, again, about 5 or 6 seconds, right? So there's nothing too interesting about that. What you'll notice is that I slightly renamed the output file. So if you check the downloaded file, you now have a cfar10 python.tgz file. And I did this just because it's not too big of a deal, but basically what you'll see sometimes online is the tar.tgz, people shorten it to just tgz. So it's just another, if you're not familiar with the terminology or these extensions, tgz is the same for targz. So that's some things you'll see. Now, in addition to MD5 sum, there's also the SHA-52 sum, and this is the one that's probably more commonly used. I think these days the MD5 sum, the MD5 algorithm, I think they've been able to find some what they call hash collisions, where the thing you don't want in a hash algorithm is you don't want to be able to put in different data and get out the same hash, right? But these things are designed by humans; they're not perfect. So sometimes these hashing algorithms, over time, the weaknesses get discovered, and sort of recommendations for different algorithms come up, just like they would for any sort of cryptographic type of algorithm out there. When they find weaknesses, they sort of deprecate some and ask you to recommend other ones. So I think the recommended hashing tool really is SHA-256 now. What I've done, and you'll see in the repository, so you can wget this file, this SHA-256 checksum file, from the GitHub repo. So if you download that file, you should now have not only an MD5 sum checksum tool, but also checksum file, but also a SHA-256 checksum file. And just like the MD5 sum rule or sum tool, you can type in SHA-256-C sum /C, and then point it at the checksum file. And it says it's okay. And you can see here that I actually made it so that this checksum file was specifically checking for our cfar.tgz, right? So because we don't even know exactly what the SHA-256 sum was from the original authors, right? They didn't post those. I created this one for you so you can sort of confirm that we are all downloaded, the curl tool downloaded the same data, and we were able to check it with the SHA-256 algorithm this time. Okay. So that's just a little bit about downloading data from the internet and uh, you know, extracting files from tarballs and checking data integrity. Those are just some of the common tools that you'll come across. So hopefully it's not too simple, but hopefully you learned a little something there. So the next section is this, at the end of each section here of commands for the exercise, you'll find the next, goes to the next exercise. So the next exercise, we're still going to be working with the CFAR data set. However, I'll just copy this link. Someone actually, didn't really like the formats of the data here and just uploaded a GitHub repo of all the images extracted. So you can actually go in here and click on an image and, apparently that's a bird. I don't know. So, yeah, so this is the next data set that we're going to work with. So it's actually all 60,000 training and test images in this GitHub repo, right? So if you just wanted to work with the raw data, the raw images, that's one source of the CFAR data set that you can use. Now, the problem is as the exercise name suggests, the more, when you start working with many files, the more problems you run into. And it really depends on the data set that you are, or the file system where you're storing the data. And that's what this exercise is all about. Now, I don't necessarily want everyone to run this command. I'm going to run this command, this first one. If you've already started running it, that's fine. But I would say don't everyone run this command because it's going to take a while. And I'll just do it myself to illustrate. Now, before I run this command, you'll notice that I've been doing something that maybe you got the impression that you're not supposed to do. I've been working only on the login node. Well, the things that we're doing are pretty lightweight, right? It's downloading files, it's sort of extracting tarballs, extracting data from these archives. That's pretty lightweight work, and that's the type of work you can do on the login nodes, right? Editing files, creating batch scripts, downloading, cloning a GitHub repo, usually shouldn't be a problem, right? So but in this case, there's a lot of files, and you can see it's going to take a while, right? There's 60,000 files to download, and we're not going to run it all the way through, right? So, and again, this is also a shared system, right? If you cancel the download, you type the top command, right? There's a bunch of other people who are using the login nodes. They're doing their own data transfers. People are SSH'd in. They're doing their own, maybe, extracting archive files. So there's computational load on the system usually doing these other types of things. So it's a shared file system. So if you're doing something that's gets a little too intense, you don't want to necessarily do it on the login nodes. Now, in this case, it'd probably be fine to let that clone keep running, but it's going to take a while. So I timed it the other day. It's going to take about a half an hour, right? But if I were to take the same git clone command and run it locally on my laptop, right, it's over in like 2 or 3 seconds, right? So what's the difference here, right? So yeah, on my laptop, it was, it took about 2 seconds the other day when I timed it. And if you're curious how I time these things, I use this time command. I guess I haven't shown it, but it outputs the time it takes to run a command. But so what's the difference here? Well, as I think Andy talked about a bit, and maybe Mary touched upon it as well, right? You have to remember when you're working on an HPC system like Expanse, right? there's different types of file systems, and they're good for different things, right? And as Andy touched on his talk, right, your home directory, where we are currently working, is an NFS network file system, right? And so what that means physically is the data that you see here in your home directory is actually coming from a different server than the login node, right? So every time you do an action on the login node and you create data in your home directory, it's actually getting created over, it's being sent over the network again to another server, right? So here in this diagram, there's the, NFS is a client server model. So there's, just like SSH, there's a client like application. So we on Expanse are on a login node, we're the client, and we're asking for the data to be mounted from the remote server into our home directory on the login node, right? But every time you interact with that file system, right, and you create a new file or extract a tarball, right, data is being exchanged over that network and through this, hierarchy of the different layers of the NFS architecture, right? So the data here that we were trying to download from GitHub, it ends up over here on this server when we're actually sitting over here on the login node, right? So this is you can imagine when you have many files like this, there's a lot of metadata operations, right? So every time you want to create a new file in this 60,000 file set, 60,000 file data set that we just tried to download from GitHub, right? There's a system call from the login node, to the NFS server. And so that's where all these little bit of operations for these little files that are getting created is really slowing down the that cloning of the repo, right? But when I do it on my local system, it's very fast because it's going directly to the hard drive in my laptop, right? It's, I am on the same node that my data is being downloaded to. And that's why you see this huge difference in the performance, right? So the lesson here is you need to understand what types of file systems you have available to you when you're working with data on these different systems, right? Now, how do you do that? Well, one command that I run occasionally, you probably wouldn't run this yourself, but you can run this this cat command here, and I'll talk about it. So I'm basically taking the output from this auto home file, which I think Andy discussed sort of the sort of standard file system layout of a Linux file system. If you remember, the etc directory is where configuration files are stored. This auto home one is just an auto home, or it's a configuration file that has to do with your home directories here. And I'm grepping for my username. So basically, I'm basically saying I want to write all the outputs of this file, just echo it, pipe it, or and then run this output through this search command where I'm searching for my username. What it shows you here is that you are on this NFS home directory, right? So on Expanse, you'll probably see that there's, if I go to a different user, right, there's actually 4 home servers. So there's actually, not only is there, so we try to spread out this load across multiple NFS servers for the different users, but every user is tied to a specific home directory server. And so what that means is sometimes if you're working on an HPC system and you have a configuration like this in your home directory, if there's one user on the system who's doing something bad to the home directory server that you're on, you might see bad performance because they are sort of abusing the file system and clogging network architecture between the file server and your access to either, working with it on the login node, or it could be even in your job, right? So how you behave on your home directory server can affect other people's jobs on the system, right? Right. If they were, I mean, we're using this Git cloning example as just a model for sort of something that goes very slow on NFS, but people doing other sort of operations on the home file server can affect your jobs as well. So one of the most common things is you don't want to run many jobs with a lot of output regularly writing to your home file system, right? As Andy mentioned, on the home file system, there's only about 100 gigabytes available to you for storage. It's really meant for like source code, batch scripts, input files, a little bit of output, right? You don't want to write thousands of files out every second from your job. That's just not what it's used for. And you're not going to see good performance, and you're going to affect the performance of other people. So another way to check what types of file systems you're on is with the this df tool. And I'm just going to copy this. It's another command that you can run that will tell you about the file systems that you're using. In this case, again, it's just showing that I have my home directory is again on this home3 server. It's got a slightly different name. Actually, what's the IP? It actually tells you like how much data is actually stored on this NFS server, how much is actually used. You can get the full output. I think I list here. If you take away the grep, you'll see. I think it's best to do this. A little crowded here. If you type df capital TH, pipe it into the less command, you can see that there's many different file systems. Again, you can see here on Expanse, remember I said there's 4 home directory servers. So here's your NFS server pool. There's going to be another one somewhere. I think pretty sure there's 4, unless we name them. There's a 1 somewhere, but it's a long list. But you'll see this tool will tell you about all the file systems that are attached to the login node, right? So there's these temp file systems. We've discussed that there's this other Ceph file system that Expanse is coming soon, so you can kind of see some of these file systems are already mounted. We're going to talk about the Lustre file system in the next exercise. But yeah, so there's different types of file systems on all of these HPC systems, and which file system you use for what purpose is, one of the first questions you want to ask when you start working on a new HPC system, right? So different centers have different clusters have different setups. Not everybody's using NFS for their home directories. I think some are even using Lustre sometimes, which has its own problems. Ceph is we're going to have as another file system option on Expanse soon. So learning what these different file systems are and how they're used is important to getting good performance, not only for your work, but also being sort of a good neighbor when you're working on these systems with other people. So the df tool will tell you about file systems, and this is kind of the most common command that I run when I'm checking out a new system and just trying to understand the different file systems that are available. Now, we're gonna, let's see, what time is it? We have till 2:15, so we have another half an hour. Okay, going a little bit slower than I was planning, but that's fine. Trying to still gauge how much material to put into this talk. So what we want to do now is return to the problem that we left, right? The problem we left was cloning that GitHub archive of all 60,000 images. What would be the best way to do that on Expanse? Well, what we're going to do next is start our first job of the day, I guess. So I have this srun commands Oh, I need to change this. Let me change this for everybody first before you copy it. I did not change this one. Apologize. You do not need to do this. I will make these changes and then you can copy the command immediately in a second. Let's see. That's the right reservation. Let me just check here. SI22 day 1. Yes, okay. So we have some reservations for compute nodes and things set up for everyone to use. Just make sure this looks good. I think so. CRL 155. Okay. So with that change in place, if you scroll down to, you reload the page and go to this srun command, you should be able to copy and paste it into your terminal and run it. Oops, something. Oh, I have a typo still. Sorry. Now, maybe this will be a good. There's also, so you can copy and paste the command. There is also in your bash RC file, there should be some command aliases that were created for you now. So you should also be able to run, I think, srun shared as a shortcut to a similar command. And that will run something that looks somewhat like this. It's not too important that you run my command from the markdown file, but if you want just the quick shortcut that I forgot about for a second was this srun shared command. So if you run that or copy and paste in my srun command, you'll be given access to an interactive, what we would call an interactive session on one of the nodes on the system. And if you type in sq-u $user, that will query the scheduler and show you your job and some information about your job. As Mary discussed, we have these different partitions. This is an interactive session with the job running in the shared partition, so that means that there's multiple people on the same node. We just allocated a few cores, I think, in this srun shared alias, just to get access to a node for a little bit, a few cores, memory, and do some examples. So we'll use this here. I have this interactive session. You can see that the name of the node or host name has changed from the login. So it sort of automatically logs you into the node that you were allocated. So if you are on your interactive session and it's open, this is what you should see. Hopefully everybody was able to do that. And now, let's see, where was I? Okay, so yeah, so you'll get assigned compute resources, and we're going to use this dfth tool to look for some NVMe drive. So I forgot to mention, if you looked on the login nodes, there's actually some other types of hardware where you see the hard disk that's actually locally on the node, just like it would be on your laptop. But on every compute node on Expanse, you have access to this scratch directory, this what we call local scratch that was mentioned. And this is on a fast local hard drive, just like you would have access to on your, say, local laptop or desktop, right? And so if you wanted to clone that repository of the CFAR images faster, doing it on the local scratch disk is one way to do that. Or, this is really just a stand-in for any IO intensive, heavy file operation type of process that you might have to run in any workflow that you're doing. You can run through your jobs, either interactively like this, or through a batch job itself, right? So just to recap, we see this hard drive there, and you have access to it in your job. The path to the local Scratch directory is a temporary one, right? It's tied to your username, and then the job ID that you, let's see, oops, what am I doing wrong? Oh, I'm not typing my name right. CD Scratch XDTR 108 job, and then your job ID, right? So you should be able to use just tab completion if you don't know your job ID. If you need to find your job ID, you can type, you can query the scheduler. Your job ID is right there. But that's how you get access to your local Scratch directory that's created specifically for you to use for this job. Okay. Now, again, I said that this would solve the problem of cloning the repo. I'm just going to copy the repo again, and clone it. And it should go very quick to just dump this onto the local Scratches. So again, it's just like using your local hard drive that's available on your laptop or desktop at work. Right. So it's when you want to do an operation like this with many files, this is where you want to do it. Right. So this is a simple example using this, downloading this data set, but it really is the location you want to use for any high IO, many small file type of operations, right? So if you're really into, say, deep learning, right? You have these large data sets with usually many small files, just like this one. And what you really want to do is you want to stage the data to this local Scratch disk and do your training from the data that's located on the Scratch disk. You don't want to leave it, say, in your home directory, right? Because that'll really slow down your training on those files as the code tries to read them out of, say, your NFS home directory, right? You don't want to do that. You want to make sure you get a copy of whatever data that you're working with and churn away on those files over here locally. Same goes if you're doing like a simulation, right? If you're doing some simulation, you're doing a lot of output. You want to write that output to the local Scratch disk, then move it back to, say, your home directory or to your Expanse Luster projects directory. Now, how would you do that, right? Of course, if we look here, we have our CFAR data now in the directory with the test and train and the different images, all 60,000 of there. Now, you can't just copy the CFAR images back to your home directory, right? Because it's not going to solve the problem of just copying 60,000 files to your NFS home directory. What you usually want to do, again, is you want to compress and bundle these files into an archive file, right? Just like the tarball we originally downloaded, right? You want to bundle all these things up, then copy that one big file back to your NFS home directory. That's going to be the most efficient way to do that. Okay. So in the examples here, what I have is another compression tool, I believe. Let's see where I got. Yeah. So if you scroll down to this zip command, this is going to do a different type of archive tool. So we've learned about tar. There's also zip. Oops. So you should be able to copy that and paste it in. And it's going to put all of the files in that directory into an archive and compress it using a different type of compression tool. And you can kind of see that you now have an output zip file, and that's what you can safely copy back to your home directory. Right? Now, something you might be curious about is like what the compression ratio is for different algorithms and tools. So you can, another tool to check how much data is in a directory is this du command, if you're not familiar. So this du command is going to -h is going to output, sort of a summary of how much data was in that directory to begin with, because I don't actually know, right? So it looks like it was about 263 megabytes for those, all the JPEG, raw JPEGs that came from the GitHub repo. And again, the compression got, everything into the archive about, 78 megabytes. So it's kind of what 5 times compression or something like that, maybe less than that. Yeah. Anyway, yeah, maybe 4. So so zip and unzip are another way to compress and create compressed archive files of these collection of files that you might want to store. One thing that's very useful about the zip tool is, I'm going to go ahead and delete the original copy here. So I'm just left with the zip file itself. I used this pretty extensively for a certain project where I had these very, very large sets of, collections of like, terabytes of data. Each sort of bundle of data was, 1,000 files each, but sometimes, so I bundled these thousands of files, these 1,000 file blocks essentially into, single zip files. And the reason for that is sometimes I only wanted to extract one of them and pull it out and use it, right? I didn't need all of the thing. I didn't need to uncompress the whole archive and get every single file. I just needed like one or a set of a few of the files that were in a given archive. And that's one thing that Zip is really good at. You can actually do random sort of, you can uncompress single files or even single directories within the archive structure. You don't have to extract the whole thing all at once. And so that's kind of what this last, I think, example in this second to last example is. So the unzip commands is how you open your archive, your zip archive. And here, the example is simply going to extract the test dog archive. So it's just, you can run that as a example, and you can see it just only extracts that subdirectory that's in the archive. So it's a useful feature of this tool that I like in particular. Okay, so we have about 15 minutes left. Oof, okay. I think this is the last. So the last part of the exercise here is very simple. What you're going to do is download this batch job script that I created for you. I think I updated it. So what we're going to do is exit our interactive session. So anytime you're in an interactive session and you want to stop, just type exit. It'll now, you'll release the resources back to the scheduler. You'll be dropped back into the home directory on the login node, and we'll proceed with our next job. And so the next job is, again, you'll copy this batch job script called download CFAR images. Hopefully it's self-explanatory. And what this last bit of this exercise is if you look at the batch job scripts, and I do have all of the, I think, correct accounting things in here, is how I would do this exercise we just walked through of downloading that GitHub repo to local scratch, creating a tarball itself. So instead of creating a zipped archive, I created a tar.gz file from that download on local scratch. And then I copy it back to my home directory and the next topic, which is the Lustre file system. So this is kind of how I structure my batch job scripts on Expanse. So again, you have sort of the shebang, setting up the environment here. You have all of the SBatch, different options for specifying the name of the job, the count, where what partitions can run, and so on. We don't need a lot here, so it's just requesting 1 core and 2 gigabytes, 5 minutes of time. And then, I define like some useful environment variables, which can be discussed, right? So in this case, we're talking about file systems and downloading data and moving data around on the system. So I have what we'll talk about next is the directories to the Lustre project storage and the Lustre Scratch storage. So everybody on Expanse has a Lustre Scratch directory here. If you have an allocation, and our allocation is this, we have a projects directory where it's used for more long-term storage. Scratch is supposed to be for short-term storage. Again, and then you can also define variables like the local Scratch directory based on the environment variables that we have our username and we know the Slurm job ID once the job starts. So you can kind of create these, use all the tools that people have talked about today, setting up your batch job script, writing a shell script, using variables and variables that come from the scheduler, variables that come from the general shell, like the user, $user, and then use the tools like cloning this archive to local Scratch. You can see I change to local Scratch, download it to local Scratch, tar it up, and then I do 2 copies. I do a copy to our home directory, so we'll get a copy of it there. But then I also copy it to this Lustre Scratch directory, and that's the job. And so the only thing part of this exercise is to run that job, doing SBatch, the name of the job script. And it should run pretty quickly since we have reservations. Okay. Yep, it ran pretty quickly. And so you'll see there's an output file here, again, from the job itself, which should just basically have the few things about the environment, cloning. Let's see, did something go wrong? Am I just not looking at the right? Something, did anyone get a successful job to run? I feel like something went wrong here. Let me try that again. Not sure what happened there. I'm pretty sure I tested this, but if there's a problem, I will fix it and get back to you. But we have about 10 minutes left. It's not too important to, oh, there it goes. So one thing I didn't mention about local Scratch, which might be what the problem is here. So this is the file I was looking for, right? So this is my tarball that came back from local Scratch. After I created it there, I copied it back to home. I also copied it to the Lustre Scratch space. So the second job works. One thing about local Scratch is, unlike CPUs and memory, it's not really divided up among the users, say, on a shared compute node. So if you're running in shared, sometimes you'll, if you use too much of the disk, and you overwrite all of the data, say you have more than a terabyte of data that you want to put there, that's going to cause a problem for other people, right? Because that shared disk is not necessarily protected. So it's sort of, you have to be a good neighbor again. You're kind of on your honor to not use too much of the Scratch disk if you're only using a few cores in the shared in the shared partition. So that's hopefully something that we'll fix on our end long term. There's ways to for the system administrators to make it, put more guardrails up, but right now there is no guardrail. So sometimes if you get a weird failure like I just did here, that could be what the problem was, but I don't know for sure. Okay, so that is the last exercise there. The next, I'm not sure what I want to go into. So we have 10 minutes. So the next section is about the Lustre file system. I might skip this. Yeah, I think the data transfer tools might be more interesting for most people. So the Lustre file system, I'll just mention, it's useful for large storage needs, right? So we have about I think 12 petabytes of storage there that you can use. There's special commands for interacting with the Lustre file system, so you'll see some of them here. I actually have the references that I'm sort of trying to compile and eventually sort of flesh out all of these tutorials and exercises from. So there's lots of good resources here that I've listed that if you want to read a little bit more about Lustre and how to use it, you'll probably understand some of the commands to follow. Eventually I'll put some text around this to make it a little bit prettier and readable as sort of a sit down sort of kind of walkthrough guide that you can do. But the big advantage of the Lustre file system is it enables parallel IO. And so if you are working with a code that works with MPIO or some other parallel file formats where you can write out large files across many different processes, across many different nodes, that's what Lustre is really good at. It's like NFS, it's not good at many small files hitting the system over and over again because it's got this distributed nature to it, right? There's all these different servers that are involved in terms of servers just for the metadata, servers just for the storage, and all this communication traffic has to get created when you're working with lots of files, lots of small files very quickly. That's again where you want to put local storage. So the same thing that applies for NFS in terms of working with small files, many files, more problems, that also applies to Lustre. So that's kind of, if there's one thing that you need to understand, that's definitely same problem happens here. The advantage is really for these parallel IO situations, and there's all sorts of things about striping and that I was going to go through, but I don't think we have time. I'd rather touch on the data transfer stuff next. But definitely scroll through here. You can run the commands yourselves. Check out the references, and hopefully it'll make a little bit of sense. At the end, the last set here is really about running an actual simple parallel IO benchmark you can play around with, and there's some nice references here. This IOR reference, I kind of have some example batch job scripts already set up, and you can run and change things around a bit. But yeah, if you work through this, try to work through this yourself, and you have questions, just hit me up in the Slack, and I'll try to answer them this week. But yeah, let's go to data transfer tools. So because in addition to working with data on Expanse nicely and using the file systems for the right reasons, the next most important thing about working with data on most HPC systems is that you probably have to back it up somewhere else, right? On our file systems, the only thing that we have backed up is your home directory. So that 100 gigabytes that we give you on the home directory is the only thing that we have like multiple copies of that we can sort of recover data from if you accidentally delete something. And it's not even everything, right? We just snapshot your home directory every so often. I think it's maybe once a week, maybe once a month. So if you deleted something today that was in your home directory last month, we probably have a copy that we can restore for you. But every other file system, the local scratch gets deleted at the end of the job, right? Your local job directory there. That's why you have to copy the data out. But on the Lustre file systems, you have purge policies. So if you don't have an allocation on Expanse anymore, your data can be deleted. If you are storing data in the Expanse Lustre scratch space, it's really meant for very temporary work. Like after 90 days, any file that's created, after 90 days, we delete it automatically. So you can't store things there long term, right? You really, anything that's important that you want to save, you need to take that data elsewhere from Expanse. And that's pretty true of most systems. Most HPC centers, I would say, focus on buying the compute resources. They don't really provide long-term data storage needs for the users themselves, like yourself. So you have to figure out your own solution. And so the one thing that we do spend money on, though, is setting up a fancy networking situations so you can transfer data off of these systems, right? And if you have lots of data, you can transfer data in and you can transfer data out. And so this is kind of a network, simple network diagram of all the places that different parts of the internet that Expanse is connected to. So there's what we call research and education networks, and that's what these are over here. So these are specialized parts of sort of the private internet, I guess you would say. I mean, not everyone has access to them, right? But if you're moving data between your university in the US and SDSC, you're probably going to go over one of these networks between Expanse and your university. If you're going from home, it's probably going to go over the public internet, and it's going to be a little bit slower if you're transferring data, right? And so that's something you need to keep in mind, right? There are different pipes with different sized tubes that the internet flows through, right? And so your data transfer is affected by where you're located, or what connections your university might have to some of these other research networks across the US or around the world, right? So this is kind of an old picture of the networks that connect to different Exceed centers like SSC, TAC, NCIS, NCSA, PSC. So yeah. Now we have, I think, 3 minutes left. I will quickly touch on these data transfer tools. So if you're not familiar with SSH and direct login, like we kind of learned about today, we set up SSH keys. A part of the OpenSSH library, which is the most widely distributed SSH sort of tooling out there on Linux systems, is SCP. So this is like the copy command that you would use on the command line to say copy a file from local scratch on Expanse to your home directory. SCP is for remote copies, right? So if I wanted to SCP my zip archive from Expanse to my local system, I can just do SCP Expanse : my home directory, and we know that this zip archive is there, right? Did I copy it back? I think so. I did not. Okay. Let me see. Let's do a tar GZ then. All right. So I have this, remember I set up my SSH config file, so I can just refer to Expanse pretty simply with, it knows that what username to use, it knows the login host name to use. And so that's, SCP is a simple tool. You can copy both files and directories. For directories, you would use the SCP -R for recursive, just like you would use copy CP-R for recursive copy on the system itself, right? Another tool is, so SCP is really simple for that. If you know exactly what you want to copy, you want to bring it back to your laptop or to your desktop at work or something. Very simple. Again, this is for sort of limited data transfer like wget, like curl. It's kind of, these tools are useful in the gigabyte size. If you're going over, say, 10 gigabytes, there's going to be other tools that you want to use, right? But that's kind of 10 gigabytes and under. for a file transfer is pretty useful for, I mean, pretty reasonable for SCP, and in this case, SFTP. I kind of like using SFTP myself. I do SFTP expanse. It allows you to sort of browse the file system. So if you don't know exactly where you left the thing you wanted to copy back to your system, you can sort of scroll around and use commands like ls. And so that tells you what files are available on the system. So if I want to do a get, say I want to download this shell script, it would do get, download CFAR images, and then you'll see you have commands where you can look locally on your system as well. So that's local ls. And so you see I downloaded the CFAR images batch job script to my local system, right? So it's kind of a nice tool if you're just, need to log in, look around. I forgot where I placed something. I wanted to copy it. And that's what this example is really trying to get at, what the main difference is. SCP is what the tool you would use if you really were, say, automating something and just wanted to copy some very structured data that you knew exactly where it was. You would bring it back with SCP. SFTP is more the interactive kind of transfer tool you'll probably use first. I think the mention here is also we have actually specialized transfer nodes that you can use instead of the login nodes. For SFTP and SCP, it's probably not going to change the transfer rate very much, but they are available. There's this interactive Oasis DM interactive node that you can use. I won't log in right now, but it's available there. Let's see. I think, yeah, we're basically over time. So the last two tools here that are mentioned, one is called LFTP, which you probably don't have installed on your Mac, or if you're using the Windows Linux subsystem, it might be available for that. But it's another FTP tool that will do SFTP and over SSH and everything. However, it's kind of nice. It has some features where you can do sort of multiple channels, so you can actually get higher transfer rates. So if you look at when I was running these examples here, right, my SFTP transfer of this file was 24 megabytes, where if I ran this with this parallel get with n channels, I was able to get up to 42 megabytes per second. So you can use different tools to get actually better performance. And LFTP is one of these ones that I've come across myself. I don't use it too often, but just to illustrate the point, there's other tools besides SFTP, besides SCP, that you can use for these sort of intermediate sized files. Like this file is a 6 gigabyte file that was transferred. So you can practice on this one. Now, I'll just take 2 more minutes. I'm sorry, I'm 5 minutes over here before we take any questions. If people are still around and want to chat. If you are transferring large amounts of data, the most important tool for you is Globus. So most universities, definitely most HPC centers, have probably some relationship with Globus, some sort of way for you to use Globus on campus, or to transfer data to and from and across these research networks that I mentioned, right? And so here's the link to Globus. Your first experience with Globus will probably be with using the web app. So if you go to the homepage there, looks like this. There's a login. I've already logged in. So once you log in, you have this file manager, and you can kind of type in like, oh, here, expanse has an endpoint, so I can actually log into my home. This is my mcandice home directory on Expanse, where I have some data if I want to transfer it to somewhere else, right? If I want to transfer it to, say, Tech, Stampede 2, right? I can see my home directories on both systems here and move files between each other. Now that's usually your first experience is using this web app. It's very cool. It's got a lot of cool features, but there's also command line tools that you can use. So I walked through a few different setting up the Globus CLI myself and getting familiar with that. And you can do everything from the command line if you really have to automate some sort of large data transfer sort of workflow between your university and Expanse, or between Expanse and a different Exceed site. Globus is really what you want to use for that. And just for the last bit of, if you have lots of data that you need to transfer, I did one very large transfer myself just to see how well it would work. And it was this training data for this climate segmentation model, sort of AI thing that I might play around with soon. And the data set was actually available from, I think it was from Lawrence Berkeley at this, from their Globus endpoint on their side. And so it turned out to be about 10 terabytes of data, 160,000 files, roughly 150,000 files. And it took, it took about 8 hours or so, and I got about 378 megabytes per second, right? So, using Globus is really perfect for these large data transfers because it knows a lot about what, networks are available to send it between these different endpoints. And for example, on Expanse, when I mentioned those that data mover nodes, we actually have 4 of them, and so they can use all 4 servers to help strike the data out. And there's all sorts of fancy things that go on behind the background to make these data transfers fast and efficient between centers. And so this is definitely the tool you want to get familiar with if you're using large data transfers. So, and that is basically it. I did have some things about long-time archival storage, but the main message is you have to back it up yourself elsewhere somehow. So that's unfortunately kind of the situation.